And so let's go into the topic, or maybe one more word from my side. I really want to thank you again for inviting us. It's a great pleasure being here. I really appreciate it. It's not nothing for me and for us. I think we still just have started to do our PhDs. So it's all kind of special, and today even more because it's our first time that we are presenting together. This wasn't planned neither. So something that we haven't done for ourselves in this focus. It's not about our research in particular. So it's more about, like you can read from the title, about Terence Deacon. We were also invited today to talk about Terence Deacon, in fact. And so this is also our goal, to give you the main ideas of him. So we won't be able to go into too many details, of course. It's all too short. But we started reading him a year ago, and it's part of our works. We include parts of his works in our works and try to develop it. And yeah, it's also part of the Pushing the Boundaries project we're working in. Yogi is our supervisor. You heard a lot of him already today. So some things are a bit in concurrence, maybe others not. So let's start. So it's up to the basics. I mean, it's a hard challenge to summarize Deacon or give you this kind of idea in short, on the one hand. On the other hand, I'd just like to try it at once right here. So also in regarding the conference, I would clearly claim that Deacon really goes beyond reductionism, and perhaps he would answer the question of what is life in a way like saying life is a teleodynamic process. It refers to a specific form of self-organizing. We just heard a lot about self-organizing as well. Deacon is also drawing a lot from the ideas of Rayla, of course. So of self-organizing nature of living systems, they're all far from equilibrium. And this in turn becomes impossible or possible for Deacon, and this is really important in terms of absential features, how they're called, so things which are not there. And through which constraints and thereby the limits, we also talked about that at the beginning. So it's a form of living or limits that are active themselves and lead to emergent processes as well. And so this is just in a nutshell, and now I try to unravel it a little bit with a few slides and coming all the way to what teleodynamics actually means and why this is important for us, our study, and for Deacon. So I guess for the third time in this conference, someone starts with Schrödinger. I'm sorry for that, but even a little bit different. I try to keep it in otherwise, and maybe changing a little bit. It's another perspective on it, to put equation on it as well. Although it's not about the equation, as you know, that's the time-dependent general form, but all the more important and is the question about what is life, of course. But I kept it in there because Deacon writes and discusses also the other aspects. So what you gain when you read Deacon, it's a lot of information from all different kinds of fields, also having a bit more another context about the wave equation as well, for example, and why this is important, or why this was not the whole story for Schrödinger and also not for Deacon. So what is life? In 1940, this was some sort of revolutionary jump, and basically asking two questions, like you have them here already. First one, how is it possible? And for physicists, this is kind of a counterintuitive trick that is performed, that organisms appear to make an end to the second law of thermodynamics. We also have heard already from Moritz that this is not in detail all that problematic, depending on how you understand entropy in local regions, or if you take the whole universe into account or not. But keep that aside for a moment. And the second question, if you are at this peculiar state, how is it possible for the organism to remain in this very state? So what controls and guides the formation and repair of organisms, and what makes it possible to organize with the specific ends as kind of survival or reproduction? And for the first, it was said you must use some sort of free energy, or like Schrödinger called it the next entropy, like we heard it before, of course. And that's a kind of vague, but let's jump to the second one. It seems to be quite a bit easier to answer this one. It was with the aperiodic crystal, of course, that should become a core sort of storage, copying, and variation tool. So which turned out to be, for Watson and Crick, a way to maybe an inspiring way to crack the DNA code. And so you could more or less say that the second question was solved. But what Deacon emphasized here, like Schrödinger did, that the question how we come to this far from equilibrium state or process, which is even more accurate, I think, is still unknown today. And since then, molecular biologists and evolutionary biologists maybe focused a bit more on the second question that seems more easy to answer, but not the first one. And that is also kind of his endeavor to tackle the first question, to combine it then to the second one. And this also goes back to his origins of his work and his main interest. And he's currently at Berkeley as a neuroanthropologist, Deacon. So he's also highly interested in language and how it comes about. And he had a great insight there, where his first book is also written about this, the symbolic species. And what the subtitle, you read it as a co-evolutive process, it basically is. And to have an idea that it is not all too trivial when you think about it, that from a symbolic process, like you see it here, that he draws heavily from Peirce, which is basically an extension of till Peirce comes up with this a more dyadic form of thinking or interpreting or referring to objects in the world. And he extends it with a third part. So you don't just have an object or a sign for an object, you get the thirdness, the interpretant, and therefore you have this semiotics triangle. And now this is crucial. It's important to remark for Deacon that it's now getting possible to sign to things, to point to things in the world. And even if they're not there, you have some kind of process going on. So this is the first time for him that something like the absentials, which is crucial for his work, came in from a more evolutionary perspective. So let's go further on. This is his first main work and the first really important part, I think, to understand where he comes to this very important idea of absentials and how this is interrelated with the second insight that he basically had or was keen to accumulate in a book with Incomplete Nature. So the first was published in the late 90s, and then about 10 years later Incomplete Nature was published. And there we have a bit of another thing to speak on. I mean, we have here now these absential features, and they're also fulfilling a role as a constraint, which we explain a bit more in detail later. But so far, I think you have a common understanding. This is enough. So we have some sort of environment or constraints or limits that are arising from these absences of certain possibilities, let's say. And Deacon draws inspiration also from Gödel when he comes to this absential, so that something is missing in the equation or something is missing in your system or in your proof. Of course, we know the incompleteness theorems from Gödel, and won't go into that any further, but I assume you know it far enough so that you can follow it. But this is another thread that is fascinating to follow when reading Deacon. And this is also highly important when he comes to the paradigm of machines and mechanistic approaches to describe nature. We also heard that with Orella, and there is kind of similar ideas how a machine, like a Turing machine, or also won't go in too many details here, but the basic idea that it's all strict to initial conditions, like in the Newtonian framework, that is leading to a system that is specified beforehand. And all the things that are necessary there are properties or functions, are always the things that are really in the system that you want to have in a machine and you want it to work. But you're ignorant of the all too important essentials that are referring to the constraints, which are more the things which are not there. So a bit of the inverse of what we have looked at till then. And he's using the frame of a golem, a frame from Jewish folklores that is, in his sense, described as an inanimate matter. And the difference mainly is that the living is impossible for a golem to be self-reproductive in his own characteristics. So it's no senses, no idea of meaning, and all this is implemented in this self-referential process that we are looking into more in a minute. So this is the first or the second line that is important to have in common. When you start with the essentials, that it's coming from a co-evolutive process in language and through this semiotic triangle. Now we are having to adapt these essentials into a sort of organism, and we can do that by differentiating it from the at that time more active or more prominent term of mechanisms. So let's go to the next step. We're leading now to the intrinsic incompleteness, and one more slide to emergence and constraints, and try to be short here because these are turn out to be the main PhD topics that Paul and I are following. So I'm the emergence guy and here the constraints guy from this perspective, and this is the last, I would say, the last functional pieces or the most important aspects of his theory to grasp, that through a certain kind of organization that we have in an organism, the constraints are getting an active role, so that the thing that are absent beforehand are turning into something that has an active position in an organism or in something that is organized. And from that on, we can have emergent processes. Because this is another point why Deacon is pretty clear about that a reductionist point of view won't suffice this idea of the essentials. So this is also connected to the mechanisms I just tried to explain before. And emergence is, for his term, just easily used as a technical term, not just a phrase, but quite simply as the non-reducible higher levels of organization, also referring to Wimsatt from this point. So the constraints are, we can keep it as simple as limitations that shape a system by exclusion of possibilities. So like we discussed it now. And then he phrases a bit like an activism, also similar here to the phrase of intentional properties. So he was looking for a term that best fits kind of combination of something like an intention that you have that is not only in you as a property, but referring to this idea of a feature that is absent in an organized feature, in an organized framework, from which then something can emerge. And that is basically, this is for the sake of, or in order to generate something that is absent, you need this kind of dynamics. And this is then also to understand as a telos, where Deacon later on comes up with an idea of, from thermodynamics, from thermodynamics, whereas leading to teleodynamics, which is called. So you have the telos again in it, but through a dynamical system. So that's the first part, and Paul will now try to unravel a bit of all of these special terms that Deacon is using. Let's go a bit more into detail here.
Do I still have like 15 minutes or something like that?
Yes.
Okay. So just for context again, what Deacon is trying to do is really, really similar to what we've heard in the previous talk of finding this middle ground between a constructivistic perspective, so everything emerging from the subject in some sense, or a purely objectivistic perspective where you get the problem of, okay, we don't have agency and all of that stuff is basically missing. So he's really trying to also somehow find that middle ground. and to really figure out how to deal with that bifurcation of nature that has been talked about previously. And he does a type of recontextualization that Kevin has now alluded to, which is this, what I call or he even calls that the figure background shift. Mainly, it's not looking in a very direct sense at the matter or what is precisely there in a deeper sense, but he's trying to look in some sense at the constraints, at the types of structure that hold together the thing that is there. So if we consider like a basic living thing, he's very interested in kind of what are kind of the structural dynamics that shape the way in which this organism can even be. So how is the organism limited in some sense by the constraints that bring about the organism? So not looking at the essential stuff, but looking in some sense for that which is around. So and I think the second thing is, I don't know, many of you have by now played around with ChatGPT and those types of things. I think a lot of the Deacon talk, or what he's really trying to do, could be just like using Sebastian's talk. We paste that talk into ChatGPT and then say, okay, now write that from the perspective of someone who is trained as a physicist and really focus on thermodynamics. Because like where we arrive is very similar. The route that we're going to take there is just a slightly different one. But from the structural insights, we're very similarly, or we're heading in a very similar direction. So the first quote is here is Ashby. Don't want to go into too much detail, but that's basically just saying what I've already said. So that it becomes very interesting for biologists to really look at the restrictions or constraints, and not at the present things in some sense. So constraints, as already defined previously, are limitation or reduction in degrees of freedom or variance compared to what is possible, determining similarity by exclusion. So the concept of a phase space or state space was already introduced. A constraint would be saying, okay, the thing that we're looking at can't visit all the possible states in that phase space, but we can only visit a select few of those states. So that's constraining our state space, basically. And so Deacon starts with classic thermodynamics, and he asks, okay, if we look at kind of classic thermodynamics, let's say we have a closed system, and we have a hot and a cold gas, and we mix them, basically, they tend to fall in towards an equilibrium, basically. They dissipate all the constraints, or even if we put like a little frog inside that box, the frog will inevitably die and we'll have a frog mush soup lying on the ground, but all the constraints that held together the organization of the frog, like I'm sorry for that visceral example, but all the constraints that held together the organization of the frog dissipate, and basically there are no more constraints left within that system. So what he then becomes interested in, and I've already explained that example to you yesterday, are self-organizing dynamics. Dynamics that have also been, those are basically attractor states from a dynamical systems perspective, but those are very fascinating things where here we have a bottle of water. It's like just if you open the sink in your tub and let the tub flow out, basically what happens is the water is kind of up somewhere and wants to kind of flow down. So there's a gravitational gradient. So there's energy, potential energy stored in the water, and the water wants to flow down. Now, for the geometric properties of the water and the air interacting, basically allow for a type of organization where you get a whirlpool. And what the whirlpool allows, interestingly, is that the energy gradient, meaning the potential energy that the water has stored, the gravitational energy, is depleted quicker. We all know that example that if we kind of normally take a bottle and just flip it over, you get this bloop bloop sounds, like an air bubble going in, a bit of water going out, an air bubble going in, replenishing the space that was left by the water, and the water bubble going out. So you get a chaotic motion, and the time it takes for the water to leave the bottle is longer than if we form a whirlpool, because the interesting geometric properties of the whirlpool basically allow us that there's an air column that kind of immediately replenishes or refills the space that has been left out, and the water moves out. So from a physics perspective, many people have looked at those, like that's often what's kind of thought about in the study of complex systems and dynamical systems, and many physicists have looked at those systems and have kind of asked, yeah, sure, now we have those types of systems, mustn't living processes be also those kinds of form or pattern generating processes? Because they obviously generate interesting processes and interesting patterns, and also constrain the behavior of the whole system in some sense. There's a clear constraint where the water moves after we have formed the whirlpool. We can perturb the whirlpool, but the whirlpool might form again, and the constraints will be kind of kept that the whirlpool has. The only problem that we have on a very deep level is what this does is it leads to the depletion of the energy gradient as quickly as possible. That's what I've tried to explain before. The water runs out quicker out of the tub if we have a whirlpool than if we don't. So if it's just this chaotic motion of bloop, 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 sorry for that, like I'm just trying to make that easy, but that chaotic motion takes longer than if you have the organization of the whirlpool. So the signature of self-organization is that it has many characteristics of living processes. Many characteristics of living processes bear the hallmarks of self-organization, and they're equated with dissipative occurrences within living entities. But the difference is self-organizational processes tend to expedite the depletion of the gradients driving them. So they just kind of kill themselves more quickly in a very loose sense. So the question that we have to ask in some sense, obviously those types of form and pattern generating processes are very relevant for living things. Like we have them everywhere. Like if you look at the skin of a zebra or of certain kind of feather patterns on birds, you clearly see that there's a pattern or a self-organizing pattern emerging. But we still need to somehow move on to a different type of organization that also allows us to start to bring in questions about normativity and value. But we want to still build that up from the basis of thermodynamics, because we have a very rich tradition there, and we're kind of interested in kind of can we go from there and can we build ourselves up towards something like us that still, as Schrödinger said, kind of remains in a weird relationship to the second law of thermodynamics. So again, there's a lot more, but I'm trying to keep this very close, very condensed. The proposition that Deacon brings is very interesting because he's also one of those weird loners like Rosen and Kaufman also, and doesn't really talk to many other people. So after he wrote his book, he was like, yeah, many people have suggested something somewhat similar, but he has his own twist to that. And many people have described those autocatalytic or self-referential networks in a very simple sense, or kind of autocatalytic networks or hypercycles. That's Eigen, that's a chemist, and like the autopoiesis in some sense. But few people have kind of, so with the autopoiesis you have to kind of more concretely ask now what exactly is it, and with the autocatalytic cycles you get to the problem. Sure, you have now a catalyst that creates a product, and the product then starts another catalytic reaction, and that creates the product for the first catalytic reaction to start, and you get this cycle. But you're still in this runaway process, so you still have this self-undermining quality that you're depleting the energy of what you can do basically super quickly. And we as living beings obviously don't do that. We just don't make puff and then we're gone. We try to kind of really extend the path length of our being, so the extent or the time that we live to the longest possible time. And so he suggests a very interesting system, which he calls teleodynamic system. I don't really like the telos in there because it has this kind of very directional and goal-oriented view. I kind of prefer to call it a self-constraining system. But what he basically suggests there is like we have those A's and B's, and those A's and B's, they come together to form the C. Can you see? Yeah. And the C help catalyze the D and the E's, and they form the F. And the F is basically a shape, like it's a triangle, and the natural tendency of this triangle, the geometry, it's like we could consider it like a lipid, or like a bipolar lipid that forms then a lipid shell in some sense. The nature of this process is that it starts to enclose the catalytic process itself. And then the catalytic process itself. So once we've kind of formed this minimal autogenic model, we could disturb that again and say, okay, now we cut it in the middle, but there will be some catalytic products left in there. And if there's something in the environment that's relevant, then we'll kind of get a duplication and we'll get two autogenic models. So in this case, we're kind of still like, it's very debatable. Have we already reached something that is living or not? Are we already like, is this a viral? It's obviously more viral than bacterial in any sense. There's no, it's like the most minimal idea. But the basic Deaconian idea is in some sense to link multiple of those self-organizing processes in ways to each other that they self-constrain them, so that they don't grow exponentially, but that they build their own enclosures, their own capsules, their own shells to not expand at the maximum rate, but persist being in some sense until perturbed. And then we can kind of easily go on and consider, sure, we can do different types of arrangements and constructions of those. They don't need to be circular or something like that. We could easily consider maybe there's now a molecule on the outside that if it senses the presence of other molecules, will then detach and will form something. It's a conceptually, I feel like, very interesting starting point to consider building ourselves up really from the thermodynamic towards a self-organizing basis, towards a minimal living system. And the overall structure he forms is that he says we have kind of those three types of processes. First is classic thermodynamics, so that's the frog dying in our box. Then we have the morphodynamics, which is the whirlpool, so where we really get the thing that our constraints are amplified, our constraints are strengthened, but we have the self-undermining nature that the energy gradient is also depleted as quickly as possible. And then we move on as a subset of those processes to teleodynamic, or as I like to call them, self-constraining processes that recursively self-reconstitute and reproduce their system of constraints, because that's also an essential thing when you want to consider a living being, that you want to reproduce your set of constraints, basically. That's again one of those inversions of not looking at the matter of what is there, but looking in some sense at the organizational principle. So this fits into this school of the organizational biologists thinking about organization rather than either the laundry list or something like that. And yeah, so the teleodynamic thing helps us to facilitate a nuanced understanding of the life's emergence and the intricacies of living processes. It offers a framework to explore the continuity from inanimate matter to complexities of mind and consciousness, and it facilitates the exploration of how intrinsic goals and purposes can emerge in physical system. So it's one of those attempts to really go from the very dead physical chemical world and go step by step and really start to build a bridge towards the minimal normative chemistry. So once we have really minimal normative chemistry, or the start of biology in some sense. And yeah, I think it's best to leave it at there, and maybe since this maybe was a bit dense for time reason, and that since we had to present together, maybe I'll open the floor for discussions or clarification questions.
This was time-wise the best structured presentation. So
really?
Congratulations, yes. I think that Primož was there somewhere.
You really feel stressed when it's like two people having to present and really condensing it down.
No, I think you managed to do a good job with regards to the most important things. And there's even now more room for discussion. And maybe we can catch up for the lost time. Okay, so any questions? This is in direct contradistinction to many of the things that you think are true. Self-organization is here posited as not adequate for life.
In what? Okay.
I mean, not adequate. It's like a crucial stepping stone, but it's.
See? Self-organization, still not large.
You need a special relation between self-organizing processes, and you need to couple them in a specific way for the emergence of living processes.
No, but yesterday there was a question. I remember you said, what is it that whose presentation was it that you said what they felt was missing?
Oh yes, yes.
Who
But
was
that
that?
was Gregor. Yes.
But I think we're also having a slightly different understanding of self-organization there. We're kind of really using it in the physical thermodynamic sense of self-organization in complex dynamical systems. But there's like a more general where you can say an organism self-organizes
Why
itself.
did you immediately go down the I wanted to see a little bit of a clash.
Okay, that was actually like a clarificatory question that I wanted to pose. Like, I'm really not clear on how you or how was this general physicalist notion of self-organization? What precisely do you mean by that?
I think the easiest way to conceive it is as this basically amplification of constraints that you get certain dynamical patterns that a system produces that are for a certain time far from equilibrium. So it's not a tendency to kind of fall into that equilibrium, but you get certain patterns that repeat as long as there is an energy gradient. So that's classically understood as self-organization. Like also you can conceive it in the mathematical sense or computational sense. It's those cellular automatas that you know, it's the whirlpool, it's like Bernard cells, like when you heat certain fluids, you can start to see perfect hexagonal forms on there, snowflakes and the growth of snow crystals. Those are kind of those patterns that organize and have those interesting, somehow far from equilibrium shapes that are just intriguing to look at. Like for us humans, they're mostly very easy to detect. Those, at least, that we know. I mean, that's a deeper question, but yes, generally speaking.
Okay. Thank you.
I mean, I'm not sure if this makes sense, but so Varela would say, I guess, that with this formation of identity, you get a radical interiority, right? So this is the two things that Sebastian also talked about. Sure, not exactly, but can you maybe see, like, is this only like a description of how like form organizes, or like is there a perspective arising from like these teleodynamics that you're describing?
So the interesting thing is the things that are described here are dynamical, are dynamics in the broadest sense of the term. They're not essences or something, but there's certain dynamics. So if we consider like a very basic thing like this autogenic model, then I would have a very hard time saying, okay, that has a radical interiority in a deeper sense. Deacon, and that's probably beyond 5 or 10 minutes to explain here, but Deacon then shows that you can apply those things recursively onto themselves. So you can have homeodynamics of teleodynamics, and you can have morphodynamics of teleodynamics. And most importantly, you can have teleodynamics of teleodynamics, meaning you can have within an organism the self-representation of an teleodynamic system. So an organism can represent itself in itself in some sense, which then would lead to what I would call this radical interiority. So it creates this intermediary zone where you have a system that in some sense has minimal living properties, but it does not yet have a sense to self-represent itself. Once you get towards, and that's also kind of the Levin work, then once you get to certain forms of multicellularity, or once you get towards kind of more complex ways to store information in the broadest sense of the term within yourself and a form of yourself, then you start to get towards something that approaches a sense of self by having this representation of the self. But this is kind of this only happens after you have kind of teleodynamics of teleodynamics, because you need to internalize representation that is also living and alive in some sense of yourself. So this really creates a liminal space between those two phase shifts.
But yeah, of course you would have it, and I would say that like Deacon writes in Incomplete Nature, that from matter emerges mind is this teleodynamic process then. So for the interior, if I get your question right, I think it's sufficient to say yes, it's coming from teleodynamics. Would Deacon answer probably?
So, one thing, I would never defend the idea of radical interiority with regards to Varela, but it's I understand what you meant. Just want to correct this because there are people in the room that I don't want to be misunderstood by. So the question is related to what Ella was actually asking. The question of teleology. It would seem that Beacon is kind of trying to reintroduce it in one way or another, but probably understands it somewhat differently. So if you could maybe say a few words on this, is it also maybe somehow related to what Yogi was saying about this attempt to reintroduce certain other classes also of causality and rehabilitate them, so to provide them with a more, let's say, scientifically acceptable attire?
Well, in a way, yes, but in not that partially or backwards perspective, like to Aristotle in the sense, but maybe in an updated version. Deacon speaks from the third evolution that is happening now for evolution, in fact, so that we had this entelechia and antelos and the old ones, like Nietzsche called them, or the old Greeks. And then we came into this area of, or time zone, phase shift to this mechanistics, like we also discussed a lot. And now it is going to be a kind of a convergence of both, but in a different sense, like we try to articulate. But it's more, like Paul said, coming from thermodynamics, it's really more physical, biological link that is happening there, and so strongly coming from a co-evolutive process where you need some kind of modern version of entelechia, which is in the telos, but the frame is kind of misleading, like Paul also said. So it's more this self-organizing thing that substitutes what we have maybe thought about as being a telos. So he really struggled to find the right phrase for it with this intentional features. But that's more or less the idea, if that's more to your question.
Yes, thank you. Yeah, Konrad.
Thank you for the talk. I will go back to your questions to my talk when it comes to what the questions were related to the relationship between the concept of boundary and the concept of constraint. So right now I'm trying to make my mind around this relationship, and I actually don't know how to think of it, because on the one hand it seems to me that, well, my intuition, let's say, is that certain boundaries, or boundaries in general, produce constraints. Like, for example, to take just some obvious example, like the physical boundaries of this glass produce certain constraints for whatever may happen with the water inside, let's say. But on the other hand, when it comes to what I call interactional boundaries, or like certain boundaries in the social domain, like when you have this street fight situation creating certain boundaries for you, there it seems that the constraints, the specific constraints in this particular situation produce boundaries. So I really don't know which direction is the proper one, or perhaps neither of them. So I guess that my question is, one question is, what do you think about this relationship? And the second question is there any explicit use of an abstract notion of boundary, not just the physical boundary of a cell, in Deacon's work?
Yeah, thanks for the question, and I really appreciate that you're directly asking us and not Deacon in the first place, or our opinion. And I think that's, from my point of view, links to what Gregor talked to us about functions and structure and the relation of it, where I would like to claim that how I understand Deacon and interpret for my kind of work is that we'd like to synthesize both. So I would say the idea is that constraints are a way of thinking the structure functionally and not divorcing it anymore. So you don't have a boundary that gives you constraints, you only have constraints. And in a sense, depending on the perspective you have, how deep you go into the material, we all know this is not just unstable wood here, but also quantum fluctuations and all of that stuff. So, in the flow and also in the process. So maybe it opens up that you have now a notion that holds for this, but also for other scale perspectives, leading to a sort of scale invariance perspective that could be useful for scientific endeavor, of course. And so I would say it's not that abstract as well. I would say it's highly directed and linked to a physical thing, and it's a kind of bridging the gap or minding the gap between the physical and the just abstract thing, like Deacon is also writing a lot of that thing. So that logic has, in a sense, a direct connection to mathematics, a direct mapping or various mappings, but the point is that it's not possible then anymore, or not that easy to divorce these two things. So I would say constraints is leading to a disjunctive synthesis to some degree. Yeah, maybe you want to.
No, mostly agree. I think you can map them well onto each other, boundaries and constraints, and that since you said one begets the other, I think that's the whole point of Deacon in some sense, that constraints beget constraints. He just doesn't really use boundaries but uses constraints in terms of that, and that the constraints have this clear link, or can have this clear link, to a dynamical perspective and to their intrinsic shifting and unstable in some sense nature.
Maybe also saying that boundaries are sometimes thought about highly passive. And this is maybe just a change of saying it's active as a boundary. Yeah.
Which resonates very much with what really this like the Denkfigur, so the main Gestalt, that the Gestalt form in some sense that Deacon really comes from, is really this inversion of not looking at what's there, but the thing that constrains, or the boundaries that bring about the thing that is there in some sense. So that you don't need to focus on this very human, essentialistic perspective of just this object, but you can kind of see the dynamism and the context surrounding it on a deeper level.
Jump in. So the real, metaphysical mystery here, and a real puzzle for me, and I use metaphysical in the fully purposeful sense. The real mystery is how these dynamic constraints produce more or less or relatively static boundaries of the world as we see it. Because, for example, the boundary of this table is a relatively static thing. It is just there, and tomorrow it will be there probably as well. How it comes about, this is the mystery here. How our interactions, our cognitive interactions, and various other interactions going on in the world, how they can be ontologically productive, as I used to put it. Yeah, this is something I would be really interested in.
Yeah, I fully agree that is kind of how can we actually get to the notion of staticism in some sense is often not asked, because we just say, oh, we don't need staticism and only need to turn towards process. So I fully resonate with that. And I think the approaches, or two approaches, are either kind of looking at different time scales, and that the stones and the constraints of the stones and the atomic movements in the stone just function on a very different time scale than we do. But then still you require the observer. You require the observer to call this thing wood or stone or something like that. And I think this is what he is trying to do with saying you have this teleodynamic or autogenic loop. And in some sense, on a very deep level, the emergence of the first autogenic loop, that's still ongoing. It has evolved and kind of branched out and gone into different niches and so on and so forth, which is the evolutionary process. But the stability is provided by that teleodynamic, autopoietic, or something like that, whatever you want to call it, basically self-referential loop that maximizes that attempts to maximize its own existence in some sense, or the duration of its own existence.
Okay, thank you very much. Let's have another round of applause.